Hello, welcome to the spring semester. This is IE4355 Facilities Planning, and my name is Eduardo Perez. I am an associate professor at Texas State University, and I'm going to be your instructor this semester. The first thing I want to do is to make sure that you're in the right place. So again, this is IE4355 Facilities Planning. I am your instructor, Eduardo Perez, and we're going to meet every Monday and Wednesday from 12:30 to 1:50 p.m. in classroom 4106 in the Ingram Hall. So the agenda for today's lecture is the following. We're going to start with a course introduction and motivation, specifically how facilities planning is relevant for some of the things that you're going to be doing as an engineer. Then we're going to talk about the syllabus. We're going to state the rules for the class, and we're going to answer questions about the expectations and so on. Then I have a brief introduction about myself, things that I do outside the classroom as part of being as a faculty member here at Texas State University. So we have a research component that is also attached to our teaching component. So I'm going to talk briefly about my research interests and the projects that I'm working on. And if you have some interest in working with me, you can contact me and we can discuss. And then we're going to close the lecture with some information about email communication, what to do, what to write, how to write an email. So let's start with the course introduction and motivation. So the first thing I like to do every time I start a class is to ask the students, what do engineers do? So this is one of those questions in which sometimes we find the students are not necessarily as um, clear in terms of how to answer this question. So an engineer is someone who solves problems of interest to society with the efficient application of scientific principles by refining existing products or designing new products or processes. So for example, I have here a drone. This is one of those devices that have been evolving through the past few years, and now they are very capable. In this case, we are looking at one that is used for photography, but there are many other applications, including um, delivery of supplies and for military applications and so on. The other thing that I like to discuss with the students is the creative process for or what we call the engineering method. This is a general framework that could be used to solve any problem that is related to engineering. So basically, we start with developing a clear description of the problem. And I believe this is the most important, or not necessarily the most important, but the most critical part, because you need to have a good understanding of the problem in order to find a good solution for it. If you don't understand the problem, then the solution that you are going to create is not going to solve your problem. So after you have a good understanding, a clear description of the problem, then you identify the important factors. The important factors are those that are making a difference. So typically when you're solving a problem, you know that there are many variables, but not all of them are going to have an impact on the solution or in the specific problem that you are going to solve. So that's why we need to identify those important factors, because those are the ones that are going to have more weight in terms of the decisions that we are going to make. And using those important factors, then we're going to propose a model or the developed model, which we are going to use to conduct experiments. And throughout the experimentation, we are going to make decisions. The next step I show here is the manipulation of the model. So basically, you manipulate the model to study different scenarios. And after you go through the experimentation, you confirm the solution, and then you provide some recommendations. So in the case of operation research, the type of models that we are going to develop are mathematical models. These are models that are constraints, have constraints, have an objective function, and these are equations, mathematical equations that we are going to define. And using a combination of equations, we are going to solve a mathematical model. And then that model is going to provide us with some decisions that are optimal for the problem that we are going to study. So why study facilities planning? Facility planning determines how an activity's tangible fixed assets best support achieving the activity's objectives. So, for example, in manufacturing, the objective is to support production. So, in manufacturing, typically you have a space, it's a limited amount of space, and you want to make sure that you can use that space in the best way possible to support your production. In an airport, the objective is to support the passenger-airplane interface. In the airport, we are interested in, for instance, providing a good service and experience for passengers in the check-in process. So that involves the layout of the queues, the layout of the inspection lanes, the layout of the travel document checkers. As a matter of fact, right now I have a project that is funded by the Department of Homeland Security that is looking at those aspects. So, okay, so if you have this layout, how many resources do you need throughout the day to make sure that you provide that good experience to your passengers? How to measure that experience in terms of the amount of wait time for those passengers. So you want to get them through the checkpoint as fast as possible, but making sure that you maintain a high level of safety and security. And in a hospital, the objective is to provide medical care to patients. When we talk about facilities planning or facility planning, we have two major components, and those are depicted in this figure. We have facility planning in terms of facility location, and we have facility planning in terms of facility design. Most of this class is going to be focusing on the facility design, the structural design, the layout design, and the handling system design. The facility location will be also discussed towards the end of the semester. So location is the placement of a facility with respect to customers, suppliers, and other facilities with which it interfaces. So for example, if you think about HEV, you see all the expansion that they have in at the IE35. So when they make decisions in terms of where to place their next supermarket or their next warehouse, they have to look at different data, and they need to find the best place to put this new facility with respect to customers, suppliers, and other facilities. The structure consists of the building and services for the facility. The layout consists of all equipment, machinery, and furnishing within the structure, and the handling system consists of the mechanism by which all the interactions required by the layout are satisfied. So for example, are you going to be using forklifts? Are you going to be using some type of conveyors and so on? In terms of strategic facilities planning issues, this is at the location level, number, location, and sizes of warehouses and or distribution centers. Also, another issue would be centralized versus decentralized storage supplies, raw materials, working process, and finished goods for single and multi-building sites. Acquisition of existing facilities versus design of model factories and distribution centers of the future. Interface between storage and manufacturing, and the movement of materials between buildings and between sites. In terms of facility design, there are two major approaches. The first one is what's called the sequential approach, and we're going to compare with the integrated approach. So in the sequential approach, it's very straightforward. You do one thing, then the next one follows, and it's a very 1, 2, 3, 4, 5 step process where there's no feedback. So you start with the product design, process design, facilities layout, material handling system design, and production planning. The integrated approach provides some interaction between all the steps. So they are not isolated, connected one to one in a one-to-one way. In here, you have some interaction between all the pieces. So the integrated approach provides good results in terms of reducing costs, improving quality, and other performance measurements. Because since everybody is notified about the decisions that are being made, better information, better transparency, then that additional information that is received throughout the process can help improve the next stages in the cycle. So when we talk about layout design, which is what's highlighted here, these involve planning for the location of machines, utilities, employee workstations, customer services areas, material storage areas, aisles, restrooms, lunchrooms, internal walls, offices, and computer rooms for the flow patterns of materials and people around, into and within buildings. So as you can see, this is a long list, and all those things need to be taken into consideration when you're designing the layout of a facility. Characteristics of the facility layout decision. Location of these various areas impact the flow through the system. The layout can affect productivity and cost generated by the system. And the layout alternatives are limited by the amount and type of space required for the various areas, the amount of type of space available, and the operation strategy. So what this is referring to is if you're designing a facility from scratch and you have, let's say, 3 departments that are in charge of production, and you have 1 department that is in charge of management and so on, you need to know what is the amount of interaction that is happening between these departments in order to make decisions of where to place them within the facility. What you want to avoid is to have 2 departments that have a lot of interaction being located too distant apart, right? So think about that, and let's say that instead of planning for 3 departments, we have 50 departments. So the process gets very complicated, especially if you have multiple departments that have high interaction. So that's the type of decision and the type of design that we are going to be trying to solve using the tools that are going to be presented in this class. Um, Layout decisions tend to be infrequent, so these are not things that you are going to do every week. Typically, when you are designing a facility, it's a long process, but you don't do those decisions quite often. They're expensive to implement and study and evaluated extensively. These are long-term commitments. A layout problem may be to determine the location for a new machine or to develop a new layout for an existing production plan, or to develop a layout for a new production plan. A layout problem may arise due to changes in the design of a product, addition or deletion of a product, change in the demand of a product, changes in the design of the process, addition or deletion of a process, or the replacement of equipment. Proper layout enables higher utilization of space, equipment, and people, improved flow of information, materials, or people, improve employee morale and safer working conditions, improve customer-client interaction, and provides flexibility. Poor layout costs you time and money. How a facility layout can save you money. This is an example of the McDonald restaurants. They implemented this list of changes in their layout and they save a lot of money, 100 million per year in food costs. So the first thing that they started doing was not food prepare ahead, except the patty, meaning that you don't discard any food that you have prepared beforehand. They eliminated some steps in the process and shortened some others. They improved some of the machines were faster, like the toasting machine that took 11 seconds instead of 30 seconds. Repositioning condiment containers, which require only one motion and not two. Sandwiches assembled in order, production levels controlled by a computer, and discard only meat when sandwiches do not sell fast enough. That created again a savings of $100 million per year. Some of the facility innovations at McDonald's over the years, they were the first creating the indoor seating facility in the 50s. The first one introducing the drive-through window in 1970. There was the first one to added the menu for breakfast in 1980, and also adding the play areas in 1990. 3 out of the 4 of the layout decisions are layout decisions. 3 out of 4. So the question is, which one isn't? Here we have a representation about the layout levels. Um, just want to give you an idea of the type of decisions and how they change according to the level of the decisions that you are trying to make. So for example, at the global level, you have site location and selection. At the super level, you have the site planning. So that's why after you select the site, you start planning for the facility. And once you have the facility building, then you can start building department and block layouts at the macro layout. At the micro layout, you start looking inside the departments for the design of the stations. And the sub micro layout, then you're looking at the actual stations, how to design them for your workers or your staff. So here's some more detailed explanation. At the global level, we select the site location. These involve factors such as freight costs, labor costs, skill availability, and site focus. So labor cost is one of the most important ones. So for example, now we see that most of manufacturing processes in the United States are being sent outside. So production, and that's related to labor costs. At the super layout level, we plan the site. This includes the number, size, and location of the buildings. It includes the infrastructure such as roads, water, gas, and rail. This plan should look ahead to planned expansions and eventual site saturation. The macro layout plans each building, structure, or other sub-unit of the site. Operating departments are defined and located at this level. Frequently, this is the most important level of planning. Macro layout institutionalizes the fundamental organizational structure in steel and concrete. The micro level determines the location of specific equipment, and the sub-micro level focuses on the individual workers, the individual stations. For that, we use our knowledge of designing workstations and ergonomics. And now we're going to go over the syllabus. So in terms of my office hours, I'm going to be holding virtual office hours using Zoom. The link is available here in the slide and also in the syllabus. So you can download the syllabus. It's available in Canvas. And the passcode to access the Zoom live session is Perez, P-E-R-E-Z, as stated in the syllabus and also in this slide. Office hours are going to be Mondays and Wednesdays from 9 a.m. to 10 a.m. and also Mondays and Wednesdays from 3:30 p.m. to 4:30 p.m. In addition to my office hours, I'm also providing you with some of my information. So for communication, the first or the best way to communicate with me, or the main way to communicate with me electronically, will be my email address, which is listed here. And then I am also giving you some of my social network accounts here, just in case you want to follow me, because I typically exchange information using in terms of job opportunities and internships. If those becomes available and people share them through these accounts, I will forward them using my account. So if you want to look at those and if you're interested in getting information about internships and jobs available, you can follow me using those accounts. The teaching assistant responsibilities includes grading the homework assignments and the labs. Also, he or she will help me in preparing the class materials. For example, if I need some copies and so on. So if you happen to know the TA, please don't talk to the TA if you have questions about the course, or if you have questions about the grading, go first, contact me, and then we can talk to the TA if there's any misunderstanding, or if you feel like you should deserve better credit in one of your assignments. You can come first to me, and then we will talk to the TA. The course objectives for facilities planning are: the main objective is to develop an understanding of the principles of facilities location, layout, and material handling systems, and to practice designing facilities. The course will emphasize modeling, design, and analysis techniques, and it will provide a balance of exposure to available methodologies in facilities location, layout, and material handling. In terms of the specific objectives, are to learn formulation models and analytical procedures for the study of facilities layout planning, to learn fundamental principles of material handling, and to be able to design layouts incorporating product, process, and personal requirements. These three objectives are more related to AVID, so I'm not going to go through them in detail. But these are the things that we need to make sure that you get from this course in order to satisfy the requirements from AVID. So to apply engineering design, to produce solutions, to develop an ability to recognize ethical and professional responsibilities in engineering situations, and to develop an ability to design, develop, implement, and improve integrated systems. Um, how we will pursue these objectives? 2 times a week, this class will meet for 75 to 80 minutes. I'm going to be recording the lectures and going to post them in Canvas. And Dr. Perez will use the modules option within Canvas to post the lecture slides, the assignments, and the due dates, and provide additional instructions per lecture. In terms of the assignments and labs will be posted in Canvas using the assignment tools. The students will upload their solutions in Canvas using the assignment tool, and feedback and grades will be available in Canvas also in the grades tool. The course textbook is Facilities Planning by Tompkins, White, and Boozer. This is one of those traditional textbooks that is used by most of industrial engineering universities in the United States. So this is the best book for facilities planning. The exam schedule is presented in this slide. There will be 3 partial exams which are listed: exam 1, exam 2, and exam 3. Those are going to happen during the class time period. So those are scheduled during our class period. And then the final exam is on Wednesday, May 11th from 11 a.m. to 1:30 p.m. The final exam is going to be comprehensive, so it will include all the material for the semester. In terms of homework and labs, there will be homework and labs will be assigned. Only some of the homework problems will be collected for grading, and I will announce which problems will have to be submitted. So for example, if you have 10 problems in one assignment, I can ask you to submit only 3 and will let you know which ones you need to submit. I will provide the solution for the rest of the problems so you can practice at home for the exam. Assignments are due at the beginning of the lecture and will be submitted using Canvas. So you will have to submit the assignments electronically. Submitted work must be professionally presented without exemption. No late work will be accepted. Makeup assignments will not be given. Any students who fails to submit a graded assignment on time will be awarded a 0 score, unless there exists a legitimate medical emergency reasons and valid documentation is furnished. Labs are practice problems assigned during the lecture time. You'll be required to work and submit your answers online using Canvas before the end of the day for the class period where the lab was assigned. In terms of the grade distribution, I have a policy in which if you are happy with your grade after the 3rd exam, you don't have to take the final. So that the grade distribution with the no final exam option is on the right. Okay, so in that case, you have 10% for homework and labs and 30% for each partial exam. If you decide to take the final, then the grade distribution that is going to apply for you is the one on the left, in which you have 22% per partial and 24% for the final. The grade distribution with the final exam option is helpful for students that do not do well in one of the exams, on the partial exams. So the final can help them improve their grade. The course grade is as follows. I follow the standard curve. Without the final, grades are truncated. Thus, an 89.999 will be a B. I have not seen that in my 9 years of experience. Okay, so Um, but I just wanted to let you know that if you have a 87, 88, and you don't take the final, that's going to be a B. So you will have to take a final for improve your grade. If a test is missed, you must have a written authorized excuse. If possible, please let me know before the test, otherwise I must be notified within 2 days of your return to school. Missing an exam without a written authorized excuse will result in a 0 grade for that item. Any disagreements regarding a grade received on any material must be discussed within 1 week of the return of the graded material. So if I give you if I post um, the scores for an assignment today, then you have a week from today to make an appointment with me or to discuss the graded material. What I'm trying to avoid is to have students asking for revising homework or assignments at the end of the semester. Okay, so you'll have the opportunity to check on or to request me to revise your grade. Just make sure that you do it within the 1 week of the return of the graded material. Attendance and diversity, equity, and inclusion. Attendance and participation in lectures are encouraged. However, no grade will be given for attendance. If you come to the classroom, do not arrive late or leave the classroom during the lecture unless it's an emergency. In terms of diversity, equity, and inclusion, in this course, we are committed to learning together to think for ourselves. So pursuit of this idea relies upon civil behavior towards all course participants such that all have an equal opportunity for learning regardless of gender identity, gender expression, race, color, national, or ethnic origin, religious belief, political affiliation, age, marital status, sexual orientation, ability status, veteran status, familiar background, or any other reason not related to intellectual merit. Participants in this course are expected to assist in sustaining this inclusive community. Health, wellness, and safety. So this is a very important topic that we need to discuss. This is information that you have received already via email. So we are going through a pandemic right now. We are encouraging students to follow these 5 steps to continue our face-to-face experience. So we are encouraging students to get tested, also to stay home and get tested if you develop some cold-like or other COVID-19 symptoms. We are also asking them to report to VOCAP Trace if you test positive for COVID-19 or have had any close contact with someone who received a positive test result. Reporting information can be found on the Texas State COVID-19 Testing Reporting and Response Steps webpage, and the link is there. Isolate if you test positive for COVID-19. Stay home and away from others for 10 days from the start of symptoms or the positive test if you have no symptoms. Quarantine if you have been identified as a close contact and stay home for the prescribed time period. Okay, so connected to this, that's why I'm going to be posting my lectures, lecture videos in Canvas, and that's why I'm not going to give any attendance grade for the class. So you have the flexibility to stay home and watch the lectures, and also work on the assignments and the labs if needed. So you have that flexibility. Face covering and vaccination protocols. Every member of the university community is urged to get vaccinated and wear a mask indoor, regardless of vaccination status. Together, we can reduce the risk of infection and transmission of COVID-19 and live out our shared values of respect and compassion. I want to make a special request, not as an instructor or as a professor. I'm making this request as a parent. I have two little girls that are under 12 and they are not vaccinated right now because they don't qualify for the vaccine. So I don't want to get infected in the university and then bring that to my house. So please, I really encourage you that at least during my class to wear a face covering and to continue um, to help us contain this virus in our campus, because that's the only thing that is going to keep us face to face throughout the semester. So please, this is a personal request. If you can wear a face mask or a face covering during my class time, I would really appreciate that. Academic integrity. It is the responsibility of the students and instructors to help maintain scholastic integrity at the university by refusing to participate in or tolerate dishonesty. You can refer to this website if you have questions. In my class, plagiarism will not be tolerated and will result in an F in the course. Also, if you have any type of disability, please send me an email or schedule a Zoom call with me and we can talk about the accommodations that you need. In this slide, we have the topical outline for the semester. So if you want to go be proactive and read some of these book sections before coming to class, that would be great. So I have posted the topics that will be covered per day and also the sections in the textbook that are related to that topic. In this part of the lecture, we are going to talk about the email communication. Uh, Part of the idea of this lecture is to help you develop the professional way of sending emails. So when mailing a teacher, now you're a student, but in the future you're going to be an engineer. So this is very important. It's going to be very relevant for you. So always include your full name and course. Include your class and what the email is specifically regarding in the subject. So here we have an example. So in the subject, this is IE4355, question about homework 3. I need to know the class. I need to know the course because I'm teaching another class with a different subject. And if I don't, and if you ask me a question and I don't have the information about which class you're referring to, it's going to be very difficult for me to answer that question. And then we go through this process of me asking you some information that you can provide me from the beginning. The basics, you have an example here. So you provide the name of the instructor and then you state the question and then you put your name at the end. Try to keep the email brief. Respond to emails within the same time span you would do for a phone call. Most of the email communication that you're going to receive from my part is going to be sent it to the entire class. If I send you an email specifically to you, make sure that you answer that email quickly because that means that something happened. Okay, so check for spelling, punctuation, and grammar errors before clicking send, and use a professional font, not decorative. In terms of the attachments, basically what I want to say is if you're going to submit a document, please use the PDF format and also provide a name that could be easy to, like if I save it and I read the name of the file, I know what the file contains. Good topic for an email. You should email your teacher if you have any easy question that can be answered in a paragraph or less, or you have an assignment that you are allowed to submit via email. Bad topics for email. There are some rules that is best to follow, such as don't try to turn in an assignment through email if your teacher has specified against it. If she had to get an extension for an assignment, please let's schedule a Zoom meeting and let's talk face to face. Don't bring up any topic that will require continuous conversation because if things become heated, there's a large risk for misunderstanding. So in that case, it's better to talk face to face. The last part of this lecture is the instructor introduction. So a little bit about myself. I am from Puerto Rico. I did my undergraduate degree in the University of Puerto Rico in Mayagüez. Graduated in 2004 with a Bachelor in Science in Industrial Engineering. After that, I worked for a financial institution and then moved to Texas to pursue a PhD also in industrial engineering. Graduated in 2010. Also did a postdoc at Texas A&M University and finished that postdoc in 2012. And after that, I transitioned to Texas State University. So as I mentioned at the beginning, we have a component. We faculty members in the industrial engineering program. We have a research component. In addition to teaching, we do research. And I have a research lab. You can find more information about my research lab in the English School of Engineering webpage. And there I have students working for me, graduate students and undergraduate students. And we do projects, research in healthcare systems, engineering and analysis of patient flow. Basically, we implement tools, we develop tools to help hospitals make decisions in terms of resource allocation, resource alignment, resource assignments, and so on. I also have a project that looks at the reliability analysis and maintenance decisions for wind energy systems. Currently, also have a project with the Department of Homeland Security that is on improving the passenger flow at the airport checkpoint terminals. And I'm actually looking for an undergraduate student to work with me in that project. I have a position, a paid position. So if you're interested in simulation modeling, specifically with Simio, you have experience, or if you are, if you want to learn, just contact me and we can talk. Also, I have a project with the National Science Foundation in which we are analyzing the data for Texas for the COVID-19, the number of cases, the number of deaths, everything. We have a database from the state, and we are currently studying some of the trends related to COVID-19 in the state of Texas. So I also have a position open for an undergraduate student. So if you're interested in data analysis, if you're interested in learning about the current trends in the state for COVID-19 and so on, we have a pay position also available. And finally, we have a project with the Texas Workforce Commission. This is not necessarily a research project. This is more a practical project in which we have students making reliability assessments for different products that are manufactured by people with disabilities in the state of Texas. So the project is basically looking at the reliability and the quality of those products, and we are comparing those with the leading brands. So for example, we are making tests for the reliability of pens, reliability of ink cartridges, reliability of gloves, and so on. So we also have some pay positions for that project. So if you're interested, you can send me an email and we can schedule a time to talk. So multiple opportunities. If you are interested in doing some research work or some additional practical work, looking to make some money, there's some opportunities in my research lab. Okay, so that's the end of the lecture. And now there's time for questions. So if you in the classroom, you can ask your questions now. If you are watching the video, you can send me an email with your questions and we can set up a time to talk.